My name is Virgil Dobjanschi. I'm a software engineer at Google. I work in the Android application group. I'm also the author, more recently, of the official Twitter app. I want to welcome you to this session. Today we're going to talk about the development of REST client applications. Before we begin, I would like to invite you to view live notes and ask questions regarding this session by using Google Wave. I'm going to give you just a few seconds to write down this URL if you haven't done that already. While you're doing that, I just want to gauge your opinion about the Froyo announcement. Were you guys impressed by this announcement? By everything we announced today in the keynote? Thank you. Well, I work in that group and I'm impressed. I'm amazed by the amount of stuff that happens in that group. And I invite you to go to all the other Android sessions this afternoon, learn about Android Cloud to device messaging, and all the other great ways you can, all the other great lessons you can learn and you can use when you're developing Android applications. So we have a lot of content to cover, so let's get started. So what is REST? REST stands for Representational State Transfer. It is a broadly adopted architecture style. This architecture style is comprised of clients and servers. Clients make requests to the server to get or change the state of a particular resource. Servers respond to the client with representations of resource. So what is a resource? A resource is any meaningful concept that can be addressed. For the purpose of this talk, I'm going to reference back to the Google Finance API as a simple example of an API. So a resource, in case of the Google Finance API, is a stock portfolio, which is characterized by its name and the currency in which it operates. The representation of a resource is simply a document that fully describes that particular resource. In case of Google Finance API, is an XML document would simply describe that particular resource in terms of its name and the currency, and maybe its ID for the purpose of referring to that particular resource later on when you need to update it or you need to delete it. REST is in no way associated with HTTP. You can use any transport protocol, but certainly HTTP is the most common used transport protocol for the REST-style architectures. There are a large number of REST APIs available today. Google Code offers already a host of such APIs. Social networking sites such as Twitter, Facebook, MySpace already have a very rich REST API. You can find on the web all kinds of information-based REST services for calendars, for flight schedules, and so forth. The first question you're going to ask yourself before you start the development of a REST client application is, why would I possibly develop an application like that if the service that I'm connecting to already has a mobile-friendly website? In other words, why don't I just use the browser to connect to that service and I'm done? Well, until the browser technology catches up, I have 5 reasons for you. I hope I can remember them all. The first one is that your application, your Android application, will be able to integrate with the Android platform. It will be able to use intents, content providers. It's going to be able to access all the private APIs available today only to Android applications, things that, at least at this point, you can't do from a browser. Your application will be able to invoke intents, not only to pick photos, but all the other intents that are today available for all the applications to use. The second reason is your application can offer intents to other applications. In other words, you're going to be able to enrich the behavior of the platform by offering new functionality to other applications. Content providers are there for you to access. The context content provider is a very popular content provider. lots of application expose it. The second reason is your applications can run in the background. What does that mean? It means that if you would like to have your application refresh the data from the server and new data is actually retrieved from the server, your application has the option to present a notification to the user to let them know that that particular data is available. A browser can't do that. Your application runs on devices with limited connectivity. What does that mean? You're going to try to initiate some of the REST methods, and they will sometimes fail because you operate in environments just like here at the conference where the network comes and goes. An Android application has the option to run in the background and retry operations in the background by using an alarm, for example, for the purpose of relieving the user for trying to hit that refresh button or post button in the browser. Your application can actually be faster than a web browser. Your application has the option of retrieving all that network content in JSON or some binary or some XML format, parse it, and store it in a database. From there on, when you want to retrieve new content, you may have the option of retrieving only content that's newer than the one you already have or older than the one you already have, but not the same data. You're also not retrieving all the HTML that comes along or any kind of JavaScript that might be quite big and might take too long to download. Finally, your application has the option of being consistent in terms of user interface with the rest of the operating system. You can innovate in many ways to deliver a fantastic user experience to the user. If you have participated yesterday in the user experience talk, please take advantage of those UI patterns. Your application is going to be so much faster and easier in some cases to use than the browser. And finally, when users are presented with the option of using a web browser versus a REST application, I can guarantee you that most users will choose the REST application. Before we begin, I would like to describe the way a novice programmer would approach the development of a REST application. That's not you. You guys know it all, but just for the purpose of this discussion, let's look at these things. Hopefully, it won't take you 10,000 tries to get there. But I can tell you that I make these mistakes myself. It's actually human nature to try to learn as little as you can about a particular thing and move quickly forward and say, OK, I'm going to have this app ready in 10 minutes. And I'm going to say, slow down. Get all the facts first. Learn what's correct. Implement it correctly so you have a good base for your application to get going. So you're a Java programmer. You have looked around in the Android SDK a little bit. And you say to yourself, I know what an activity is. How hard would it be? I'm just going to create this activity. I understand a REST method takes a long time to execute because I need to connect to a server, so I'm going to run it in the context of a thread. You decide that this thread is going to be an inner class of your activity. And you decide that you're going to store all this data that you retrieve from the server in memory. Maybe the application I'm describing here is your attempt at displaying the list of stock portfolios that I have already set up for my own account in Google Finance. So you get your application to run. It runs fast. It doesn't crash. So why is this not the correct approach? You have to understand how the Android operating system works. And the Android operating system was designed to work on devices with limited memory. What does that mean? It means that, for example, when the operating system is attempting to start a new application and it ran out of memory, it needs to make a decision about forcefully shutting down an existing application. So how does it make that decision? Well, the answer is you have to help the operating system make that decision. If your application does not have a foreground activity running, in other words, a visible activity running, or a service running, the operating system can say, OK, well, this application is not currently displayed to the user, is not currently performing any operation, so it's safe to shut it down. So let's now go back to our diagram and try to understand what's wrong with this picture here. Well, here's what happens here. You launch the thread that initiates the REST method, and guess what? You pause your activity because maybe a phone, incoming call needs to be answered. What happens is the operating system says, oh, well, this particular process doesn't have any foreground activity, so you know what? I'm going to kill it. I'm going to forcefully shut it down. Well, guess what? Your post, put, delete method maybe has executed on the server, and you'll never learn the result of that particular method in your app. You execute a get method. You get all this data in. Once you get it and you parse it, you're happy. Operating system will shut it down for you. Wasted bandwidth. Another thing that's wrong with your approach is that you decided to store the data in memory. So you say, well, hang on. My application is fast. Well, the reason why that's not a good idea is because by having to repeatedly retrieve data from the server, either because the user has simply restarted the device, or simply because at one point your process had to be forcefully shut down, you're wasting CPU, you're wasting battery, you're wasting network bandwidth. That's not a great way to write an Android application. And for those of you who are going to say, well, it's much faster to get this data from memory, I'm going to say, by using a content provider, you have the option, should you consider that necessary, to cache this data in memory. So that's really not a good reason to say, I'm not going to store my data. As I said, none of you will probably write the application this way. So let's describe today 3 design patterns that you can use in your applications that would give the best user experience and the best performance. These are not the only 3 patterns you can use. Once you look at them, once you understand what they're all about, you can possibly create your own. That's great. As long as your application complies with the basic principles that we're laying here for you, it's OK to continue to innovate from here. We're not going to talk about implementation details. I'm not going to show you code. Hopefully you like that. So let's introduce these 3 patterns. One is based on the service API. One is based on the content provider API. And the third one is simply a variant of the second one. We're going to use a sync adapter. This is an advanced talk. Last year, we got a lot of feedback from you guys saying that some of the sessions were too light. Well, we decided to compensate this year. Even though it's an advanced talk, I'm going to try to introduce these concepts, which some of you may not be familiar with, so you understand the basic idea behind it. So let's get started with the first pattern. The first pattern makes use of a service. Again, for those of you who are not familiar with a service, is an Android component that does not interact with the user, and it's specifically designed to execute operations in the background. It runs in the context of the main thread. We can call that the UI thread. And in order for you to execute these operations, you need to still create a worker thread in the service. Some people think that by simply starting a service, I can simply execute in the context of the thread of the service that particular long-running operations. That's false. So now that we understand that the service exists in the platform and has, by the way, a very simple API, you can either implement the services API by using an intent API or by using a binder interface. By the way, for the purpose of this talk, we're going to use the intent API, which is, by the way, a little bit easier to understand. We can now get started with this first pattern. This diagram is not exactly simple. To best understand it, we're going to take a bottom to top approach by explaining the role of each component. And once we're done, we're going to do one example starting from the top and running through an entire code flow to see how this works. So let's get started with the REST method. What is the REST method? Really simple. It's an entity which has the ability to prepare an HTTP URL, to prepare the HTTP body in some cases, execute the HTTP transaction with the server, and process the response, which typically means parse the response from the server. There's not much to say about this. Let's make some performance remarks. Many REST APIs offer today the ability that you select the content type of responses. Prefer them in this order: some binary format, AMF3, whatever is out there, JSON and XML. We're happy to announce that if you choose JSON, we have a brand new implementation of org.json API. It has exactly the same API as before, but it performs much faster. There's very little garbage collection going on. For those of you who have tried the older version, you're going to be very happy with this particular implementation. Enable gzip if the REST API that you're using allows it. Gzip is a very fast library. It's a native implementation. Sometimes you get compression ratio to 5:1, 10:1, depending on how much data you're retrieving. And by doing so, you're simply speeding up the download of data that you want, plus the battery life will be preserved better in this case, because the radio will be in use for less amount of time. Always think about the radio, always think about the network and the implication it has on the battery life of that particular device. Always run this REST method in a worker thread. You understand that an HTTP transaction takes time to implement, sometimes a long time if a timeout occurs. And you should never run such operations in the context of the main thread. And finally, use the Apache HTTP client, not the Java URL connection. All right, so what do we have so far? We have the REST method, a simple API. It fires back a Java listener callback. Really simple. Let's take a look at the processor. The role of the processor is to mirror the state of server resources in your local database. We're going to use a database. The role of the processor is to say, OK, this is the state of this particular resource. So to better understand how the processor works, we need to create this concept of a resource in the database. Well, it's really simple. It's exactly one row in the database. In the case of Google Finance, it's a row that maybe has the ID of this particular resource, the name of this particular portfolio, and the currency. And we're going to add two more columns to that. One, a status column, and two, a result column. The status column is the one that simply indicates the transitional / at rest or steady state of that particular resource. What that means is that every resource, when it executes a REST method, has a transitional state, right? While you are executing this particular transaction, the resource is not yet in sync with the server, so we want to keep track of this particular state. Your question is why? Why would I possibly need this? Two reasons. One, your user interface may want to display maybe a little icon next to the resource that says, oh, well, I don't have to stay in the activity that actually started this post, the creation of the portfolio. I can just leave that activity. And my list of items is just going to display a little icon next to that particular resource saying, I'm in the process of synchronizing the resource. But go ahead and use the app. I'm going to let you know when that's done. When that disappears, that's a good indication that your resource has now been synchronized. So in the status database, we're going to hold some flags. These flags are going to say, I'm in the process of executing a post method for this particular resource. I'm in the process of updating, deleting this particular resource. And we're going to use one more flag to say, we're in the process of executing an HTTP transaction for this particular REST method. Now you have a full description of what's going on. At any time, you can just look at the database, say, OK, I know exactly what's going on with this particular resource. The result method can simply hold the HTTP result of the last REST method you executed in regards to that particular resource. So now let's come back to the processor. The processor executes before and after the REST method executes. Before the REST method executes, in case of the post method, it's simply going to insert the content. It's going to create a row in the database. It's going to call an insert method to create the row that corresponds to the resource we need to update. We're going to set the flags to posting, meaning we're in the process of executing a post method for this particular resource. We're going to say, yep, we're also transacting, by the way, so we're going to set that flag too in the status column. And we're finally going to initiate the REST method. REST method completes, let's say successfully in this case. We're going to update the row in the database with the help of the content provider. We're going to clear the state posting flag because that particular method is no longer pending. And also, we're also going to clear the transacting flag so we know we're no longer transacting with the server. Put works very similarly. It's hardly worth going through this, but we're going to update, before the REST method executes, we're going to update this particular row in the database. We're going to set the updating flag, meaning we're in the process of updating this resource on the server, set the transaction flag, execute the REST method. Once it's done, update it again, and clear the two flags that we just set, if everything goes right. By the way, as you well know, most correct REST API implementations are idempotent. It means that you want to send a document to the server saying, OK, I want to change the state of this particular resource on the server. And you send this document representing the change you want to make. And the response that comes back, it's the full description of that particular resource as the server sees it. In other words, the state on the server side. That's why it's recommended that you go ahead and update again. Although many times that's not necessary. It's up to you to decide. But either way, in this case, you're going to have to clear the flags. Delete. Very simple. You're just going to delete, tag that particular method for deletion. You're not actually going to delete the resource. Why? Because we have not yet successfully executed the REST method. You go ahead, execute the REST method, it succeeds. Finally, you delete that row. Finally, you're done. Your user interface, by the way, in this case, has the option of saying, well, you know what? If the state deleting flag is set in the status column, I'm not even going to bother displaying that particular resource. Or you have the option to display a little, again, synchronizing resource right next to that particular resource to know that we have not yet deleted it, but we're about to. By the way, these flags can serve a different purpose. What happens when you need to retry these operations? Well, wouldn't it be great to know what exactly do you need to do? The posting flag would mean, oh, I need to execute a post method. I'm going to look at the transacting flag saying, is there an HTTP transaction already posting? So if that's the case, I'm not going to start another one. If it's not, I have the option of saying, OK, well, let me retry this. Maybe the network didn't work last time. But that's a great way to mirror the state of the resource in the database and retry these methods. Get, simplest one of all. There's nothing to do. Processor has nothing to do before the REST method, inserts the new resources once it gets them from the server. This could be the list of stock portfolios. Maybe you have many of them on Google Finance. One more thing to say about processors. They execute database operations. Never execute database operations or content provider operations in the context of the main thread. Sooner or later, you're going to run into application not responding errors, the so-called ANRs. It's not good practice. Learn to stay away from that. Also, use transactions when you use SQLite. Not only will they preserve the data integrity, but they will increase the performance of your database operations. We have the processor, we have the REST method. The processor has almost the same API as the REST method. It goes through. But this time, we're able to mirror the state of that particular resource in the database. We said at the beginning that it's not a good idea to start long-running operations in an activity. That's where the service comes in. The role of the service is to simply allow your application to execute operations in the background while an activity is long gone. I'm going to say it again. An activity comes and goes. It's just the user interface of your application. The user has the option to hit the home button, hit the destroy button, in other words, go back home. Your long-running operation is still executing. And the nice thing is that you have the database, simply store the state of that particular resource in the database, and when you come back to your application, regardless of what happened, you can simply learn what happened. Did it work? Is it still pending? What's going on? On the forward path, the service simply receives an intent. We said we're going to use the intent-based API. It unpacks the content of that intent, which is just think of it as a map. You know, oh yeah, I passed in, for example, the name of this particular stock portfolio and the currency. I'm going to extract it from there, make a Java call to the processor, done. On the return path, I'm just simply going to handle the processor callback, and I'm going to invoke what's called a binder callback. What's a binder callback? The binder callback, think of it as an interface that was passed in the request intent. So the upper layer says, OK, when you're done with this particular operation, I want you to invoke this binder callback and let me know that everything worked or failed. Here's another thing you can do in the service. You write a social application, and all of a sudden your UI needs to download 10, 20 images just because you're scrolling really fast to that list. Is it a good idea to download 10, 20 little images at the same time? The answer is no. Be nice to all the other applications. They might need the bandwidth at that time. Implement a little queue in this particular service. Allow maybe 1, 2, or 3, as it is the case in your application, for parallel downloads of these particular images, especially if these particular images are larger. Always think about the other apps when you're writing one. And finally, the service is a stateless component. Everything it needs, it receives the intent, fires the callback. Unless you implement the queue we were just talking about for downloads, there's no reason to keep any state. And most importantly, while all the pending operations have completed, shut down the service. If you don't, the operating system is going to say, well, this guy's busy. Let him keep the memory that it wants. Let him do whatever he needs to do. Be nice, again, to all the other applications. Shut down the service once you're done. It's very easy, we're going to say, for the purpose of the service helper, to stop the service, or the service can stop itself. There are many ways to do it. You have no excuse to leave that service running. Almost there. We have a service with an intent API and asynchronously fires a binder callback interface. Sometimes preparing these intents is not that easy, or at least not elegant, I know that. And handling the binder callback is not something we should leave as an exercise for the reader. What we should do is have a very thin layer, we call this the service helper, that prepares these intents for us on the forward path and handles the binder callback on the return path. So the role of the service helper is to simply expose a very simple asynchronous API to the caller. Let's say we want to create a portfolio. The name of the method is create portfolio. Here's my name. Here's the currency. It returns the request ID, which uniquely identifies that particular pending REST method. It's a singleton. There's nothing to it. You make this call, and here is what the service does. It's much simpler than it looks. The first thing you may want to do is have the ability to ask the question, is this particular REST method already pending? That's certainly not the case with create. But if you do maybe a get my stock portfolio list, what if you issue this request and some other activity, which quickly you switch to, issues yet another request? Well, you certainly don't want this particular situation where, let's say, you're downloading and parsing the stock portfolios in parallel in 2 different threads. It makes no sense. So you can protect yourself in this particular pattern. Here in the service helper, you can implement a map from the request ID to this intent. And you can always, first of all, ask the service, is this particular request ID still pending? You can do something else. You can look at the values, the intents in the values method, and say, by looking at the intents, you will be able to answer the question, is this particular type of operation, maybe even with these parameters, already pending? And if yes, you'll simply return that request ID to a user, and it's a nice way to get around some of these problems. And finally, you put the operation type, you put any method-specific parameters, such as the name and the currency, you set the binder callback, and you finally call start service, which simply sends that service to the service that we discussed earlier. On the return path, really easy. You get the binder callback, and this time you say, OK, this particular operation is no longer pending. And you can dispatch a callback to any listeners. Listeners are typically going to be activities that would like to know the result of this particular REST method. One interesting discussion here is what kind of data should I pass from the service to the service helper? And you're going to say, OK, you just retrieved that list of stock portfolios. Should I just pass it on? Should I just move all that data through this particular binder callback? Well, think of it as a marshalling interface. In other words, something that has to cross process boundaries. Well, you don't want to do that. Keep as little data as possible in that particular callback. For example, you can say the result of this particular REST method was 200 OK. You can say, here's, by the way, the original intent that I used to start this operation. Maybe the caller would like to analyze the content of that particular intent to remind itself what it was executing at that time. All the data you already stored, you already retrieved, it's already in the database. The activity has the option of simply saying, OK, thanks for letting me know. I'm going to go and retrieve that content. There's absolutely no harm done if you choose once in a while to pass some data through this binder interface. You can use any parcelable, think of it as serialization technique, to send data over this interface. The less data you parcel, the better it is. So we're almost done. The service helper has a simple API. If there are any listeners that register, these callbacks go back to the activity. Let's look at the activity. Always remember the activities are paused, resumed, or destroyed. They have their own mind. They have, better said, their own life cycle. Think of them, again, as just user interface that is either controlled by the user. In some cases, activities pop in front of your application just because maybe a phone call comes in which case the application will be paused, the activity will be paused. In onResume, we have the option of adding a callback to the service. Say, OK, I'm back. I'm interested in what you have to say. On pause, remove that, because if a callback will occur while your activity is paused, sooner or later you'll get a crash. You're trying to access this activity while it's paused, and that's certainly an incorrect technique. Always consider these three cases. A request method is started by the activity. The activity just sits there in the foreground. Everything is nice. It gets the callback from the service helper. Easy. In case of an error, you can say, I'm sorry, I couldn't perform your operation, or hey, cool, we created the stock portfolio. What if the activity starts the REST method, pauses, it comes back, it resumes, and now the callback occurs? Well, that's not much more difficult. However, you can still handle the callback. Everything is great. In this case, you may need to store the request ID so you know to ask the service helper, is this particular request still pending? And so in onResume, the answer this time is going to say, yep, it's still pending. OK, so I'll just wait for the callback. Nothing special. Third one is the most complex. REST method is started. Activity is paused. REST method completes. While the activity is paused, activity comes back to life and resumes. What's happening? Well, in onResume this time, you're going to have, again, the request ID that you started. And you're going to say, well, is this request still running? And this time it's going to be no. It's not. Okay? So now you understand why we chose to store the result in the database. The application has the option to go back to the database and figure out exactly what happened with this particular pending request while it was maybe destroyed, maybe paused, and so on. Remember, that operation, that long-running operation, the REST method, was running because it executed in the content of a service, and the operating system said, OK, I'm just going to leave this particular process alone because it's executing what it thinks that's important. So that's great. On the return path, here we have the option to receive callbacks from the content provider itself. The content provider supports what's called content observers. Content observers are simple ways to receive notifications from the content provider when data changes for a particular set of entries in a particular table. That's a simple explanation, but that should do. In other words, you can monitor the status of a particular row, or maybe all the rows, all the resources in that database. We reached the top. Let's go take a full example and run with it. The activity decides to create a portfolio. It says, OK, I'm going to call this simple method in the service helper called create portfolio. Service helper says, OK, I'm going to new an intent, packet it everything I need, the name of the service, the currency, the binder callback, the type of operation. I'm creating a portfolio. The unique request ID, it calls start service. It says this particular operation is pending and returns the request ID to the caller. The caller has the option to use this particular request ID to find out if this particular REST method is still pending. Finally, the intent gets the service. The service unpacks it, makes a Java call to the processor. The processor said, what kind of method corresponds to this particular Java method? Ah, this is a post. I need to create a new stock portfolio. So I'm going to go and insert that content into the database. In other words, I'm going to create a row in the database. I'm going to set the status posting. I'm going to set the transaction flag in the status column. And I'm going to say, OK, I'm ready to execute my REST method. The REST method prepares the URL parameters, prepares the request body, if that's required. And for Google Finance, that's certainly the case. Gets the callback once the REST method transacts with the server. It obviously gets the parsed result back from the REST method. The processor says, OK, I'm going to update the state of this particular resource in the database. So it updates the content. It updates the flag by saying, OK, this particular method is no longer pending. We assume, obviously, that it worked. And the content provider would fire notifications as needed if there are any kind of content observers. On the return path, processor says to the service, thank you, I'm done. Service says, OK, I'm going to invoke the binder callback that was already in the intent. And finally, if the service helper says, you know what, this REST method is no longer pending, I'm going to let any activities know about the result. And the activities have the option to handle that callback and display error to the users and so forth. So that's a quick run through this particular design pattern. Next one, based on a content provider API. What is a content provider? For those of you who don't know, is a simple way in Android to store and retrieve data across process boundaries. Typically, a content provider sits in front of the database. It offers the insert, update, delete, and query methods that, in the end, access the database. Really simple stuff. I can't go into details. Hopefully, that explanation will be sufficient for the purpose of this discussion. So the first question you're going to have for me, OK, how in the world did you get to the conclusion that you can use a content provider API to initiate REST methods? Well, the answer is simple. There's a one-to-one mapping between REST method types and some of the methods in the content provider. So the get REST method corresponds to query in the database. The post REST method corresponds to insert. The put REST method corresponds to update. And finally, the delete REST method corresponds to delete. Really simple. It's not hard to imagine how this works. So here's the pattern that we can use. Let's say, by the way, in this particular diagram, the service helper, the service, the REST method work just as before. The content provider and the processor have a slightly different functionality, and we can cover that once we go through an entire flow to this particular diagram. So let's assume, as before, that we would like to create a stock portfolio. The activity says, OK, this is going to be a creation, so that corresponds to a post. Obviously, I'm going to do an insert. It calls the insert, prepares the content values for those of you who are not familiar. It's just a way to specify the values that you would like to insert in specific columns in the content provider. Calls insert. Content provider says, OK, I'm going to create this row for you. And before it returns, however, it does a trick and says, I understand that this particular operation needs to execute a post REST method. So it initiates, with the help of the service helper, the post method. It returns the URI of the newly inserted row to the caller, the activity in this case. And it simply says, OK, I inserted it for you. And by the way, I'm going to keep the transactional state for this particular resource. The state posting will be on. The transactional flag will be on. Transactioning flag will be on. And finally, the activity has the option to use these flags, should it need, to display the status of this particular resource while it's transitioning in the UI. That's up to the application. Or choose not to show it at all, or whatever policy you would like to institute. Finally, the service helper calls the service, executes the REST method. Once the REST method successfully executes, the processor says, OK, because the REST method succeeded, I'm going to clear these flags. I'm going to update the row. And the activity, maybe a cursor adapter, or any content observer, will have the ability to understand that this particular, the status of this particular resource has been updated. By the way, in this case, if the REST method fails, it's the responsibility of the content provider to say, OK, I'm going to set up an alarm here. And maybe after 5 minutes, I'm going to retry it. And maybe I'll implement some nice exponential backoff so I don't keep retrying, and kill the battery in the process of doing so. Please note that in this particular pattern, we broke the content provider contract a little bit. For insert and update, everything works as expected. You're calling insert. We insert the resource right away into the database as a row. For update, we do the same thing. We update the resource as a database. For get, we do something funny. In other words, for query, we do something funny. We go to the database first. We'll get the rows that already exist. Now we have a cursor, and this is the cursor that a query typically returns to the caller. Now, if the activity would like to retrieve brand new, fresh content from the server, it has the option in the query URI to set a flag and say, I would like to also get the latest data from the server. So the content provider says, OK, not only am I going to give you the results in the cursor, but also I'm going to let the service helper know that it's time to execute a get method, maybe in the refresh mode, to say, just give me items that are newer than the one I have. Delete breaks the contract. For delete, you say, I'm going to just tag this row for deletion. I'm not going to delete it right away. And finally, the row gets deleted once the particular delete REST method has completed. It's not a big deal. You just need to think about it. And maybe once you display your results in a list activity with a cursor, again, look at the flag to see what is the state of that particular resource in the database. There are other ways to do this. You can remove the row from the database, possibly move it to another table where you're going to be able to retry delete requests. Again, we're not forcing you to adopt these particular design patterns. The last pattern is simply a variant of the previous one. We're still going to use the content provider API, but we're going to use the help of a sync adapter. How many of you know what a sync adapter is? I was afraid of that. The sync adapter is a concept that you should learn as soon as you get home and you start developing for applications. What it is the ability of the system to help you synchronize remote and local content. The system employs the help of a service manager, a sync manager. The sync manager manages all the sync adapters from across all apps. The sync adapters are simply services started by the sync adapter. The sync manager, I'm sorry. The sync manager implements a queue of sync adapters. In other words, if you say, I would like to sync my data, there's a request sync method in the sync manager. It does not mean that the sync manager will say, sure, right away. What it does instead, it queues the execution of this particular sync adapter behind any other sync adapters that need to execute. By the way, even if the queue is empty, the sync manager has the option of saying, OK, I'll get to it. Why does it do that? Why doesn't the sync manager just run out there and start your sync operation right away? Well, the reason is because it's trying to preserve the integrity of the entire system. What if you start your Gmail sync with the email sync, you develop your own app, all of a sudden you have 4 apps executing these sync operations in parallel. They all do network transactions, they all do parsing, they all do database operation. It's a mess. Don't do that. Also, when you, obviously the sync adapter is going to help you. It's going to prevent you from getting into that trouble. But the characteristic of a sync adapter is that it does not execute maybe as fast as you would like to. So with that in mind, let's look at this pattern. Activity works the same way. You need to create a stock portfolio. You call insert into the content provider. The content provider creates that row in the database. It sets its transitional state to whatever it needs to be. That's it. It returns to say, thank you, I'm done. So how does the REST method execute? Well, that's where the sync adapter comes in. Well, I lied. The content provider, before returning, calls request sync. It says, when you have a chance, come back to me, start my sync adapter. The sync adapter starts, looks in the database, and asks, are there any resources that are in the transitional state at this point? Yes. Here's our resource. It needs to be posted. It goes, reads the row from the database, starts the REST method, executes it, gets the result, updates the database, and it's done. What if it fails? Well, awesome. The sync adapters have the ability to handle errors nicely. In other words, I should say the sync manager. The sync adapter is responsible for simply throwing errors back to the sync manager. The sync manager says, there was an error while I tried to sync this. You know what? By implementing exponential backoff, I'll queue this particular sync adapter behind any others, if any, and I'm going to restart this sync when I have a chance. All that is already there for you. You don't have to write your code with alarms. You don't have to do all this stuff. All you have to do is learn how to report errors from the sync adapter to the sync manager. All our applications use the content of the sync adapter to refresh content. Gmail, email, all these apps use that particular concept. Please use it in your apps. In conclusion, please do not implement REST methods inside activity. It's poor practice. An activity is a piece of user interface. It's no different than any other Java framework you work with. There's a clear separation there between user interface and functionality. Always start a long-running operations from a service. Also, always stop the service if all the pending transactions have completed. Always remember that the service executes in the context of the main thread. If you need to execute these long-running operations, start a worker thread in order to execute these operations. SQLite is your friend. Persist early and persist often. What does that mean? Post, put, insert that data in the database as soon as you can. Update it as soon as you can. Once you get the result, do it again if you think that's a smart thing to do. Please don't let your database grow infinitely. Think about this. You keep getting new items from the server, and all of a sudden your table holds thousands, tens of thousands of items. Well, your database grows. It is the responsibility of your application to possibly purge all data. Why is that a good idea? Not only because the user will be mad at you because you made their phone useless, but because the cursor has the ability to hold only about 1 megabyte of data. Beyond 1 megabyte, it will have to do windowing, which is a very slow operation. Don't hold a lot of data in these cursors. For example, images. If you use images in your cursor, which absolutely you could, what you're doing is you're taking away from your ability to store more items in a cursor. Minimize network usage. Only request data that's newer than the one you have, older than the one you have, but don't go back to the server and get that data again. Page data. If you don't page data, you're retrieving this huge amount of data from the server. It takes time to retrieve it. You parse it. It takes a lot of time to parse it. You insert it in a database. That application will never perform fast enough. Always use paging. Hopefully, the REST API that you're using supports paging. Finally, use a sync adapter to synchronize the content of your local database with the state of your server. We're very happy to announce here at Google I/O that the Android cloud-to-device message is now available. You won't have to set up an alarm in order to continuously start the sync adapter and ask the server, are you done? You have new data? Do you have new data? Use the push notification. Of course, it takes an effort on your behalf. I warmly recommend this afternoon's session on the Android cloud-to-device messaging. You would save a lot of battery life for a particular phone when using that technology. If you use all these techniques in your REST method, and you create your own, let us know, by the way. We're happy to hear from you. You will create awesome REST client applications, very performant, and the user will simply enjoy using it maybe over a web browser that accesses that same service. Thank you. So I'll take some questions now.
Excuse me?
Ladies and gentlemen, if you have any questions, please go to the microphone, and we'll be with you in a moment.
So any questions? I'm sorry. Go ahead.
Yes, I have actually two questions. One is, what are the advantages of intent-based service invocation versus AIDL? And the second question is, would user need to approve the sync adapter in a settings account and sync UI for your sync adapter to work?
I'm sorry. I need you to repeat the second question.
The second part is would user have to explicitly approve your sync adapter in the settings UI for your sync adapter to work?
Right. So the answer to the second question is yes. Then one of the nice things about the sync adapter, it obeys the user settings on a per account basis, which is fantastic, because sync adapters are linked to accounts. So you can even say, I don't want, the user can say, I don't want this sync adapter to run all the time. It can select which ones it will actually run. Also, it obeys the contract of out of sync and data. Let's say you're traveling. What's going to happen? Well, you probably didn't subscribe for roaming, and you don't want your sync operations to go in background. The framework takes care of that, and it obeys that. That's one of the great reasons to use a sync adapter.
So in this question, if content provider kicked off the sync, but the user have never yet approved the sync adapter, it will not sync?
It's not a manual. It's not one of those permission things. It's a setting for the platform. Okay. So you have to go to settings, and not even in your application, rather in the phone settings, and approve it. I know you had a first question. I apologize.
Sure.
And what was the first question?
The first question was, what's the advantages of the intent-based service invocation versus AIDL?
So there's a difference there. That's a very complex subject. Please look at the API of a service. In order to use the interface, the binding, you have to actually bind to that service. You have to connect to it. That's an asynchronous call. And you may not want to deal with the complexity of it. The intent, on the other hand, is very simple. You can just say, here's this intent, but note that that particular operation always executes asynchronously. Whereas in the binder call, you have the option to execute it synchronously. Poor design, by the way, but you certainly have the option to do so.
All right, thank you.
Yeah.
Hi, thank you. I recently came across a very useful class called Intent Service. And I was wondering if, I mean, it seems like this would be exactly the kind of place that you would want to use that service. It handles like the threading and everything automatically. Do you think that's a good idea, or like, do you have any recommendations about using or not using that class?
I wanted to simplify the content of the presentation. Intent services are great. If what you want is to execute a long-running operation in the content of the worker thread, the intent service can certainly help you with that. In our case, however, I don't know if you picked up on this. Everything happens asynchronously. So I didn't have a huge need for it. Can you do it? Absolutely. And actually, it's a very good way of not having to deal yourself to create that particular worker thread. It will be created for you. So yes, absolutely yes.
OK. And I had a second quick question. You said that you don't need to set a flag for the get method in your database, and I'm wondering if I'm missing something, or like if there's something that might be fetching an update from the database. So it's something that already exists on the server, and I've already retrieved it before, and now I want to see if like some value in one of the fields in the row has changed, and I want to see that I'm getting updates for this row. I would have to set a state flag for
Is it too late for me to change that? No. Yes, it's a good idea. The problem is that you didn't get anything yet. What are you setting these flags into?
No, I mean, it's a resource that you have retrieved, but you want to check to see if like a value in that row has been updated.
However, the flags I was describing were specific to a particular resource, not for items that you haven't yet retrieved. That type of status is OK if you store in memory. We can, if you want more, I'm happy to discuss this with you after the set. Thank you. Let me take a question, actually, from Wave users. Fortunately, we're not going to be able to show any calls. Wow. The question regarding the Apache HTTP client versus Java, that's a very good question. I would simply advise that use the HTTP Apache client because it has a more robust implementation. The URL connection type of HTTP transaction is not the most efficient implementation. And the way it terminates connections sometimes can have an adverse effect on the network. Let's leave it at that. Sorry, let's go.
Yeah, I do have a question on, say, if you have a search use case in the application, do you still recommend to persist that in the database because the user is very unlikely that he's going to come back and use that data again at a later stage? So
you're not referring to search across resources you already have in the database?
Right, yeah.
Right, so you're going across the network. I'm sorry to say it's best left to the implementation of the app. Okay. Apps that I worked on had different requirements because this is a requirement of the user interface. For example, should you initiate requests, should you initiate these searches at every single key that's being typed, or should you wait until the user has said, OK, let me search now? Up to you. Of course, you're overwhelming the network with requests once you're doing a search, especially if you don't have some good policy in the lower layer to say, ignore this response because the user is still typing. Otherwise, you keep parsing, you keep inserting possibly results in the database while the user is still typing. So it's probably not the best way to do it. But there are absolutely, I have nothing against that.
Okay. Thanks.
Sure. I'm sorry, we have time for one more question. Not even one, I'm sorry. If you have any more questions, please talk to me right now after the session.